Welcome to this session on steam, evaporation and dehydration. Steam is defined as vapor form of water. Steam is generated using a boiler. Water is heated in an enclosed vessel and evaporated into steam. Steam is one of the most essential commodity or utility in food processing and has wide applications as a major source of heat. Steam can be classified into three major types, namely wet steam, dry steam and superheated steam. The main objective here is to generate steam as a source of heat for use in different food processing applications in the industry. Coming to the types of steam, wet steam is one which has moisture in it. The heat contained is majorly sensible heat and the steam is at saturation temperature. Dry steam is one which has no moisture in it. The heat contained is essentially latent heat. Superheated steam is one which is heated above the dry steam temperature. The heat contained is indicated as degree of superheat. The quality of steam is expressed in terms of dryness fraction. The stream dryness fraction is quantify the amount of moisture present in the steam. For example, if steam contains 10 to 30% moisture by mass, it is said to be 70 to 90% dry. In other words, it is having dryness factor in the range 0.7 to 0.9. The dryness factor for a dry steam is unity. The equipment for generation of steam is boiler. It is nothing but a enclosed vessel in which water is heated and converted into steam. Different sources of heat can be used based on the availability, such as firewood, coal, sawdust, rice husk, LPG, diesel are some to mention. Coming to the types of boilers, boiler can be classified as water tube boilers and fire tube boilers. In water tube boiler, water is allowed to pass through a bundle of tubes which are heated by hot flue air outside. The water level in these tubes are maintained at a constant level. Soft water is allowed to pass drawing from a storage tank. The tubes are surrounded by fire inside the furnace. As the water is heated, the density decreases and the vapor liquid mixture rises in the tubes and forming the vapor. High pressure steam is allowed to collect in the header pipe. A chimney is provided to allow the smoke to pass through into the atmosphere. Boiler has few safety accessories such as steam safety valve for the safe and continuous operation. It has other accessories such as softener, storage tank, flow indicator, pumps, steam pressure gauges, etc. This type of boiler generally gives high steam production rate but low steam capacity. Water tube boilers, that is why preferred in high pressure applications, since the small diameter pipes can withstand high pressure with small or thin vessel walls. Fire tube boiler, on the other hand, is one where the flue gases obtained by burning the fuel is passed through the tubes. Soft water covers these tubes. Any type of material can be used essentially solid fuel, but it can be adapted to liquid as well as gaseous fuels. Evaporation. The process of heat transfer accompanied by phase change of a boiling liquid is often a requirement in food processing technology. These processes are more complex than simple heat transfer between the fluids. A phase change involves an addition or subtraction of considerable amount of heat at constant or nearly constant temperature. The rate of phase change may be determined by rate of heat transfer. However, it is often influenced by the rate of new phase formation and also by the behavior of the new phase after its formation. A special case of heat transfer to a boiling liquid is a unit operation is called evaporation. Evaporation, as the name suggests, involves evaporation of solvent, essentially water, in food processing. By comparing this unit operation with other unit operation increases our clarity. Evaporation differs from drying in that sense what remains in evaporation is a liquid concentrate, while in drying the residue is often a solid. It differs from distillation in that the vapor usually is a single component in evaporation, normally water. Even if the vapor is a mixture, no attempt is done for its fractionation. Evaporator is different from crystallizer in the sense the emphasis is placed on the concentration of a dilute solution into a thick liquid rather than forming the crystals and growing them. Most popular application of evaporation is the production of common salt from brine or seawater by evaporation. Only a thin line exists between evaporation and crystallization in this example. The evaporation will be discussed in terms of the basic definition, the objectives, factors affecting the performance, types of evaporators, their performance, and finally the applications in food processing. The basic definition of evaporation is that it is removal of moisture in order to produce a liquid concentrate from dilute solution. The objective is to reduce the volume to facilitate both transport and storage. The factors affecting the performance to be examined. The character of the liquid that is to be concentrated itself is most important. The wide variety of liquid characteristics demands judgment and experience in designing and operating evaporators. This clearly distinguishes this unit operation from a simple heat transfer to a separate art in itself. The important property of liquids that play major role include concentration itself, both initial and final, foaming temperature, characteristics of scaling, etc. Invariably, stainless steel is used for the contact parts and mild steel is used in other parts of the evaporators. The main types of evaporators can be classified as tubular evaporators and state of art agitated film evaporators. In long tube evaporators, we have rising film, falling film and forced circulation evaporators. Coming to the mode of operation, evaporators may be operated either one pass through or in circulation mode. The extent of evaporation is limited in single pass mode and there are adopted easily for a multiple effect operation as well, where the total extent of concentration can be spread over several effects. Agitated film evaporators are always operated as one pass. One pass evaporators are especially useful for heat sensitive liquids. By operating under high vacuum, the boiling temperature of the liquid can be kept low in these evaporators. Under long tube vertical evaporators, especially the climbing or rising film evaporator where the flow is upwards, these are useful for a single pass operation where the valve in the circulation line will be closed, permitting once through operation attaining least possible retention time. This is effective where high degree of evaporation is not required. However, climbing in film evaporators are often operated as circulation units. In falling film evaporators, where the flow is downwards, concentration occurs for the heat sensitive materials. For example, orange juice requires minimum exposure to heated surface. This can be achieved in once through operation. In this type, liquid enters from the relatively large tubes from the top and flows down before they leave the evaporator at the bottom. The tangential entry of the vapor liquid mixture in the separator ensures effective separation of vapor from the liquid. Wear provided in the periphery of the tubular calendula ensures proper distribution of the liquid into these tubes. The main problem with the falling film evaporation is distribution of the liquid uniformly in the tubes. To prevent the extent of heat damage, residence time are normally kept very low. Plate heat exchangers are used for the concentration of milk instead of tubular evaporators. In forced circulation, significant improvement can be seen, especially in case of viscous liquids. The calendula can be horizontal or vertical. The heat transfer coefficients are very high and the residence times are very low due to high circulation velocities. In forced circulation evaporators, feed mixes with the liquid that is held in the tubes of the evaporator and the mixture passes through the equipment and unevaporated liquid is recirculated back to the equipment. Only part of the total evaporation occurs in a given pass. Forced circulation evaporators are well suited for heat sensitive material, fruit juices especially because the loss of flavor is involved. As they get exposed repeatedly, although the temperature is low, by maintaining the high vacuum. Forced circulation evaporation can work either in natural convection, where the circulation of flow is attained by or induced by density difference caused by temperature gradient, or with forced circulation where circulation flow is caused by circulation pump itself. Agitator firm evaporators are the state of art design. The principal resistance to overall heat transfer from the steam to the boiling liquid or juice in a evaporator lies on the liquid side. One way of reducing these resistance, especially with viscous liquids, is by mechanical agitation of the liquid film as shown in the figure. With some modifications, these are also called scraped surface evaporators. They are best suited for heat sensitive viscous juices such as mango pulp, gelatin and even antibiotics. Feed enters at the top of the jacketed section and is spread out into a thin film by the vertical blades of the agitator. Concentrate leaves from the bottom of the evaporator with fraction of residence time and vapor passes into unjacketed vapor separator. The major disadvantages are high initial cost and maintenance of the mobile parts. Also, the capacity of a single unit is very low compared to multi-tubular evaporators. The performance of the evaporators is done by principal measures, namely steam capacity and steam economy. Capacity is defined as number of kgs of water evaporated per hour, while economy is defined as kgs of water evaporated per kg of steam supplied. In a single effect evaporator, the economy is less than 1, while in multiple effect evaporators it far exceeds than 1. The steam consumption in terms of kg per hour is also an impact factor. It is nothing but the ratio of capacity to economy. Apart from the applications discussed, the additional applications of evaporation in food processing include concentration of several fruit juices such as pineapple, apple, orange, passion fruit, etc. The juice concentrate can be easily transported and reconstituted as and when required at the desired consistency at the user end. Tender and mature coconut water also can be concentrated. Honey is often subjected to evaporation in order to reduce the moisture content to increase its shelf life. Dehydration or drying. Drying generally refers to removal of moisture to a relatively low extent from liquids or solids, essentially keeping the residual moisture content to a low value. Drying to acceptable level is usually occurs in the final step in series of operations in a given food process train. Water or other liquid can be removed by mechanical pressing or even by centrifugation or thermal evaporation. The topic of present discussion refers to drying by thermal evaporation. Of course, it is cheaper to remove liquid mechanically or osmotically, that is by submerging into concentrated osmotic solution prior to drying. The following aspects of drying: objectives, theoretical aspects, drying rates and drying equipment. Drying is defined as removal of moisture to the desired level by employing heat by any modes of heat transfer, namely conduction, convection or radiation. Let us look at the theoretical aspects. Drying is a simultaneous heat and mass transfer process. The mass flux J is given by K into Ci minus Cb, where K is the mass transfer coefficient, nothing but the ratio of diffusion coefficient to the diffusion distance dx, where Ci and Cb are moisture concentrations at the interface and bulk respectively. Similarly, the heat flux can be given as Q is equal to H into Tb minus Ti, where H is the heat transfer coefficient which is equal to K by dx, where K is the thermal conductivity and dx is the heat transfer distance. Tb and Ti are bulk and interface temperatures respectively. The Reynolds analogy between heat and mass transfer is given by K is equal to H by rho Cp, where rho is the density and Cp is the heat capacity. Let us look at the drying rates in a drying process. Any given food material will have two types of moisture, unbound or free moisture or bound moisture. Unbound moisture can easily diffuse across the food material when gradient is induced by surface evaporation. The rate of drying remains constant as long as the free moisture is present in the product, since the rate of diffusion to the surface matches the rate of evaporation at the surface due to the heat transfer medium, that is hot air. This is called constant rate period of drying. Once the free moisture is evaporated or completely removed by drying, the diffusion rate to the surface significantly reduces, since bound moisture comes out very slowly. As a result, the drying rate falls gradually. This is called falling rate period of drying. The moisture content at which this change occurs, that is, the transition from constant rate to falling rate period, is called critical moisture content, MC. Let us discuss drying equipment. Drying equipments are classified mainly as conduction type and adiabatic dryers. Freeze drying is a conduction dryer and state-of-art technology. It involves freezing of the sample and removal of the moisture by sublimation under high vacuum by heat transfer. It results in high quality in terms of color, volatile retention and nutrient retention. High rehydration ability of freeze-dried products can be attributed to porous structure that obtained in freeze drying. In freeze drying, heat transfer occurs by conduction. Most suitable for low volume, high value products, especially that are meant for export. Typical examples are coffee, strawberry, peach, blueberries, raspberries, caneberries are a few to mention. The major disadvantages are high capital cost and operating cost. Further, freeze drying is a very slow process and often it is a batch process. There is a slight difference between freeze dryer and lyophilizer. In the former, after the freezing takes place, heat is given to facilitate the sublimation under vacuum. In the latter, no heat is provided to aid the removal of the moisture. In lyophilizer, very small quantities of samples only can be handled, whereas large quantities can be handled in freeze dryer, depending on number of trays available and the dimensions of these trays. On the other hand, spray drying is the most popular and competitive methodology of drying. Examples for food systems include skim milk powder, instant coffee, egg powder, soup mixes, juice powders, custard powders, etc. The basic procedure involves atomization of the liquid feed in the dryer, contacting it with hot air, moisture evaporation and separation of the dried solid product from the hot air. The advantages are low contact time, drying occurring at wet bulb temperature, continuous process and high throughput. Heat transfer in the spray drying occurs by convection. In spray dryer, atomization can be achieved either by a nozzle or a rotary atomizer. The particle size will be of normal distribution in nozzle, whereas the particle size will be of uniform size in rotary atomizer. However, nozzle atomizer can handle high solid contents up to 30%, while rotary atomizer tends to get choked at high solid content. The liquid spray and the hot air can be contacted with each other in either co-current or counter-current mode. Although the drying occurs at wet bulb temperature, the dried powder sees higher temperatures while it is pneumatically carried by hot air till the exit of the dryer, just before it is separated in a cyclone from the hot air and collected into a bin. Hence, the hot air temperature at the exit also is important parameter that is to be paid attention to minimize the heat damage to the product. Drying can take place by radiation in equipment such as infrared, microwave or radio frequency dryers. It may be noted that industrial dryers can be operated as batch or continuous type. Commonly used industrial dryers include tray or cabinet dryer, drum dryers, fluidized bed dryers, tunnel dryers, vibrofluid bed dryers and state-of-art dryers of field assisted dryers. Tray or cabinet dryer is the least expensive, that is why most common and popular dryer. Additional effort is paid to blow air between the space of trays in order to replace the moisture evaporated from the product during drying, so that the effective concentration gradient, which is the driving force, can be maintained properly. In drum dryer, a layer of thin liquid is spread onto the rotating drums, which are heated by steam from inside. The dried layer is scraped off from the drums at the end of the rotation and size reduced into powder. The bulk density of this product will be high, example is Complan, compared to spray dried product, example is Horlicks. Vibrofluidized bed dryer is a recent modification. In this, fluidization is achieved by vibration itself, hence very little amount of hot air is sufficient for carrying out the drying. In a single unit operation of heating, resting and cooling are carried out in 3 decks which are arranged one above the other. High temperatures are achieved by directly burning the fuel, namely LPG. Energy efficiency is very high due to recirculation of hot air. Field assisted dryers include IR dryer and microwave dryers. In convective hot air drying, heat transfer occurs from outside to the inside of the material, and the mass transfer of the evaporated moisture occurs from inside to outside. In case of infrared drying, heat releases at a predetermined location inside the food material on incident of IR rays, and thereby heat and mass transfer will be in the same direction, that is from inside to outside. So, less resistance is offered for the mass transfer. In convective hot air drying, case hardening of the material surface occurs as the moisture loses during the drying, offering higher resistance to mass transfer to the outside, causing severe product damage. In microwave drying, uniform heating, volumetric heating occurs. The heating is generated inside the food material mainly due to the high speed of rotation of water molecules ignited by microwaves. The disadvantage is the difficulty in controlling the drying process. Rate of heat transfer is very low in radio frequency dryers. Best part of radio frequency dryer is that the electromagnetic field self-regulates in such a way with respect to moisture present in the food material. As the drying progresses, reduces itself decrease in moisture content. Thus, the product can never be overheated and the product damage can be completely avoided. However, due to high cost, RF drying is used only for the finished drying after hot air drying is carried out, because the product damage occurs only towards the end of the drying where residual moisture is removed. In summary, it can be said that evaporation and dehydration or drying are the most popular unit operations in food processing, essentially for extending the shelf life and facilitating the transport as well as storage. Evaporation evolved gradually, starting from open pan type to falling film evaporators to the state of art agitated film or scraped surface evaporators. Similarly, sun and solar drying paved way to controlled hot air drying and eventually to field assisted drying where hot air drying is coupled with IR and microwave radiation. Spray drying is the most encountered or economical way of drying, and freeze drying forms the control for all types of drying. Thank you very much.